Hi, in this video we're going to focus mainly on parallel lines. We'll start off with just a quick aside on the distance between two coordinates. So here I've got two coordinates, 2, 2 and 8, 10, and we've been asked to find the distance between those 2 points. So by that it means, if I basically got a ruler, what would be the length of this line going straight from these 2 points? Again, it's not obvious to work out, but we could work out quite easily. We could work out how far across it is, and how far up it is. So from 2 to 8 I've gone 6 squares across, and from 2 to 10 I've gone 8 squares up. And from here hopefully you can see this is like the basic layout for a Pythagoras' theorem question. So this is my x, and we're now going to solve this. So Pythagoras' theorem again only works with right angle triangles, is a squared plus b squared equals c squared, where c is always along this length and a and b can go in either order. So a and b can be 6 and 8. And we're now going to solve this equation. Okay, and this is fairly straightforward to do. Key things to do, or key thing not to make sure you don't forget, is at the end you have to square root your answer. So x squared was 100, which therefore means that x is 10. So the distance between these 2 points was just 10. Okay, let's just go for an example like that. Here we don't have any graph to use. You've basically got 2 options here. We can do a sketch of these 2 coordinates. So minus 1, 3 will be somewhere up here, and 5, 7 will be somewhere up here. And we can then work out the distance between the x coordinates and the distance between the y coordinates. In this case, that is going to be 6 and 4. And then we can do Pythagoras on that. The alternative is to use a formula. Again, it's probably slightly less hard brain power, but in terms of memory, you've got one more thing to remember. Again, it's up to you what you prefer. The formula for distance between 2 coordinates will be the square root, and then it's y2 minus y1 squared plus x2 minus x1 squared. Okay, so this is basically Pythagoras' theorem, just sort of compresses it all into one bundle. Again, it's down to what you prefer, which method you prefer, both will give you the same answer. Let's finish using this formula. So x1, x2, y1, y1, y2 we saw before. They're just the x and y coordinates from each of those 2 points. Let's plug it all in. So y2 minus y1, that is 7, take away 3. x2 minus x1 is 5 minus minus 1. Simplifying that, we get 4 squared plus 6 squared. Note, these are the same 4 and 6 we got from here. That is the distance between those 2 coordinates. Key thing here, we're now going to work it out, but it wants an exact answer. Whenever it says exact answer, that means you cannot round it. So let me show you what I mean. If I grab my calculator and just type that in. So square root of 4 squared plus 6 squared. I get 2 root 13. And that's the answer it wants you to give you. The reason is the second you press the S to D button and you have it as a decimal, if I write any of that down, even all of it down, all I'm doing is round up my answer. That will not be the whole answer. There'll be more things to it than that. So whenever it says the exact answer, you must give it as either a square root or a fraction or something like that. You cannot round it, you cannot write down a decimal whenever it says give an exact answer. Okay, main part of this video is looking at parallel lines. So parallel lines, you should know what they are. They're 2 lines that point in the exact same direction. So here we've got these 2 pairs of parallel lines, and these are also 2 pairs of parallel lines. Now, in terms of work with straight line graphs, we can extend the definition a bit further. Parallel lines will always have the same gradient. So if I look at this, both these equations are going to have the same gradient. So this is y equals minus 3x, and this is y equals minus 3x plus 10. So this number for the gradient will always be the same. And it's the same here. Here we have y equals a half x minus 2, and here we have y equals a half x plus 3. So we can use that to solve some questions. So we're given the equation of line L, which is this top one in red here, and we're also told that it's parallel to line M, and therefore we want the equation of line M. So if it's parallel, it must have the same gradient, so this 2x must also be in line M. So for line M, I know it's going to be y equals 2x plus c. We have a coordinate for line M, and we can use it to work out what the y cut here is. Actually, for this case, we can just see the y-cut is that coordinate. So the y-cut is -1. So that's the equation for line M. Okay, let's do it again slightly harder. Again, here we don't have a graph, but it's the same basic idea. We have a straight line parallel to this, therefore it must include this -3x part. So for my other equation, I can straight away write it down. It's going to be y equals -3x plus c. And again, we're told the point it goes through, so we can just plug this in to work out what c must be. So y is 7 and x is 7. Plug in those in. I can then work out that c is going to be 28. And then we're done. The equation line, we just combine those two together. So y equals -3x plus 28. Okay, let's see how we make it slightly harder. Here we're not told the equation of the first line. All we're told is 2 points it goes through, but we know from before we can use that to work out the equation of that line. In fact, we don't even care what the y-intercept here. All I want to do for these 2 points is work out their gradient. So for that we have the formula. M is yt minus y1 over xt minus x1. We've got x1, y1 and x2, y2. Plugging that in, we can fairly quickly work out that that gradient is going to be 5 because it's 20 divided by 4. So for the parallel line, it must have the same gradient. So for this equation, the line that goes through -1, 4, I must have y equals 5x plus something. I can plug in that coordinate. So y is 4 and x is -1 because we're told that over here. And now we can solve this equation to work out c. So 4 is -5 plus c. Opposite of -5 is +5, so therefore c is 9. And then we're done. We have the equation of our line. It was just y equals 5x plus 9. So for these harder questions, they sort of bundle a few more things in from different parts straight line graphs, but it's theoretically, also in principle, the same basic idea. Okay, just go through one more example. So we have this line here. I want the parallel line that goes through this point here, and we want it in the form ax plus by equals c, where a, b and c are all whole numbers. First things first, if I zoom into this equation, it's not of the typical form. The form we like all our straight line graphs to be in, which makes everything so much easier, is y equals mx plus c. This is not in that form, so our first step, we're going to have to rearrange it slightly. I want the y by itself, so here I'm going to move this 3x across to the other side. If I do that, it's going to become negative. So this is equivalent to y equals -3x plus 10. And again, for me, it's always easiest always writing the x's first, just so you've got a better comparison to the sort of default form of y equals mx plus c. So, we know this line is parallel to L, so therefore it must also include the same gradient, which is -3x. We can now work out the plus c by plugging in these coordinates here. Okay, let's work that out. So 2 is -3 over 2 plus c. So therefore c is going to be 2 and 3 over 2. As a mixed number, if I do 2 plus 3 over 2, that is going to be 7 over 2. So it's 2 plus 1.5, which is 3.5. But for all these questions, it's always easiest to work with c being an improper fraction or top-heavy fraction. So we have this equation of the line. That is y equals -3x plus 7 over 2. We want it in this form here, where the key thing is that a, b and c must be whole numbers. So to get rid of this fraction, this over 2 part, I'm going to double this whole equation. So it now becomes 2y equals -6x plus 7. Okay, we want ax plus by equals c. So I want to take this -6x across. If I do that, it's going to become +6x. And then we're done. Okay, so again, it's still the same key idea using parallel lines. We're going to have a few more sort of tricks and tips halfway through it. Okay, I hope that helped, and thanks for listening.